Recall the definitions for average velocity and average acceleration. We can solve for the final position and the final velocity and get these two equations. Then we can solve for time in both of these equations and get these two equations for time. We know that the average velocity is equal to 1/2 times the final velocity plus the initial velocity. The final velocity and the initial velocity are not equal. The final acceleration and the initial acceleration are equal. So basically, this is just all given information. Using the final velocity, we can plug in the final velocity here, and we can plug in the time here. So first plugging in the final velocity. Well, if we plug in the final velocity here, you're going to get 2vi. That's where this 2vi comes from, plus the at. So plus the at. Simplifying this equation and solving for the change in position, we get left off with this equation here. And of course, that's using VF, final velocity. You could also use VI, initial velocity, and get this equation. So those are the two equations that we can get for the change in position. We can also get a third one by using the change in time. So using time, plugging in the time here, simplifying, and then setting this part of the equation equal to this part of the equation, cross multiplying, we get that 2 times a times the change in position is equal to this difference times this sum, which is the same thing as the final velocity squared minus the initial velocity squared is equal to 2 times acceleration times the change in position.